Everybody. Welcome back to Young Engineers of Today. Hope you had a good couple of days. You know, all that jazz. We're going to continue with Arduino. In fact, we are going to finish our Arduino circuit thing, at least programming-wise. So we'll kick this off with a little bit of review, and then we'll move on to actually working on the programming and finishing that up. So I'm going to go ahead and open up circuits.io to bring up our circuit from last time. How's everybody been these last couple of days? Oh no, I kind of am too. You been good though? Okay, that's good. Not too bad? That's nice. No, I figured you didn't mean you've been goo. I've been goo, but I got better. But yeah. All right, well, I'm glad that for the most part everybody's doing okay. Sorry to hear that you're sick though, Liam. I'm a little bit myself. If I might just randomly stop talking at certain points, it's probably because I'm sneezing. Also, I feel like my mind's been in a fog, so I apologize if I get ramblier than usual or lose my train of thought more than usual. Anyway, this is our circuit. We are using the Arduino to basically control how we're going to light up these 8 LEDs. And you'll see that in a bit. But like before, we've got a ground hooked up to our common ground here, and all of our LEDs are hooked up to the common ground through the resistor. So the resistor is actually the last thing, the last part on the circuit. The common ground is connected to the resistor, which is connected to the LED, which is connected to the appropriate pin slot. So 2 through 9 are what we're using for this. So we're using 8 of them, which is kind of weird when you think about it, because it doesn't seem like the math really lines up. But anyway, we've got eight separate outputs, all hooked up to a different LED. So each one has their own individual output. And the reason we're doing that is so we can control when one lights up. Now, I'm going to go ahead and I'm going to see about bringing up the code that I had last time around. Super inefficient program. And this is what I was talking about last time. So what this does is this, get rid of that. This sends power to all of those pins in order. So it'll turn them on, wait a half a second, turn it off, wait a half a second, turn the next one on, wait a half a second, turn the next one off, wait half a second, turn the third one on, wait half a second, turn the third one off, wait half a second, so on and so forth, repeat over and over and over and over and over again. So that's what we've done with this. That's how we've been, that's how I initially wrote the program. And I told you guys, I think at the time, I told you guys not to write this just because this is, well, like the name implies, super inefficient. There is a much easier way to go about this. Does anybody remember what that is? Yeah, a loop. Exactly. Specifically a for loop. Right. Precisely. So we've got there's sneeze number 1. We've got the means to be able to make this program so much more efficient. So what I'm going to do is I'm going to open up a new instance of Notepad just so we can compare them side by side. Actually, I'm going to write this from scratch. So we're going to have our void loop, or void setup, excuse me, and our void loop. We have the memes. We have the means and we have the memes. All right, does anybody happen to remember offhand how a for loop is structured? Or have it written down or anything of the sort? Okay, so we're getting bits and pieces here. We got a for and then some parentheses, and somebody else said something about I. So, well, so far, so good, right? Do you remember how many parts were in here? You have to make I 0. Okay, so that's a good start. You don't necessarily have to make I 0. I did my example, but you don't have to, and we'll get into that. And yes, there are 3 parts. So we're going to put in 2 sets of semicolons here. Actually, you're pretty much right on the money there, William. And you too, Jacob. Nice. Nice work, guys. All right, so yeah. So we start out with our declaration. In this case, I equals 0. Does anybody remember why we use I? Yeah, because it's standard. Convention, basically. Does anybody remember why we start at 0 instead of 1? That one's a little trickier. That mostly just has to do with the fact that counting in computers, a lot of stuff starts with 0. And loops can iterate through stuff that computers use, and so it's generally a good idea to have a loop start at 0 so you can start at the first element that exists in like an array or something like that. Now, that probably doesn't make a whole lot of sense because we haven't really gone over arrays yet, but that's okay. I'm sure we'll touch on that at some point in the future, but basically as it stands right now, it's just because that's what we do most of the time. So in order to keep things consistent, even if you're not necessarily counting something that's computer related, like if you're just counting how many times you want a loop to run, you can start it at 0. And it makes the logic in the second part a little bit simpler too. Now, fun aside fact, the reason why computers start counting at 0 is really only because when computers were newer, their memory, they had much less memory. And, a lot of times people would start counting at 1 or whatever, and they realized that they were not making use of a whole entire number, which when you had RAM counted in the order of, kilobytes, and even before that, bytes, um, that's a lot of information to just sort of ignore. Like that's a whole block of memory that you're just ignoring. So for that reason, they figured 0 is a perfectly valid number to use, and it's a perfectly good starting point. So a lot of stuff that you're going to be using in programming, if it involves counting or iteration, it's going to start from 0. Not quite. I thought there was another sneezing coming. Okay, so that's the first part, is establishing our variable and setting what it starts at. Doesn't have to be 0. It depends on your program and what you need, but it certainly can be, and it's not a bad idea. Second part are your conditions. Basically, how long the loop runs until it's done. In this case, the loop runs as long as I is less than 10. Now you might be thinking, okay, so this loop runs 9 times. In fact, it actually runs 10 times because, again, we start counting at 0, so there's an extra number there. If you started counting at 1 and you set I to be less than 10, then yes, you would run 9 times. But since we're starting at 0, we know we're running 10 times, and that's part of the reason why the logic makes it a little simpler. If we wanted to start at 1 and have it run 10 times, we'd have to set it less than or equal to 10, which is just a little bit messier looking. It's no big deal, but a little bit messier looking. So that's the second part, is the conditional. Basically, this, as long as that second statement is true, the loop continues to run. And then we've got the third one, which is the math that's done to it. Now, a lot of times that can be anything. In this particular case, we're adding 1 to I each time this loop repeats. So we know for a fact that this is going to run 10 times because I starts at 0, the loop runs once, then I gets set to 1, then it runs again, then I get set to 2, then it runs again, then I get set to 3, and so on until it hits 10. And then as soon as it hits the top of the loop, when I is 10, it goes, oh, hey, 10 is not less than 10. And it skips and moves on. It doesn't skip because it's already run the loop a few times, but it moves on beyond the loop to the code that comes after it. So that is how we increment the loop. So as a little bit of a quiz to get used to reading this kind of stuff, how many times is our loop going to run if we do that? Now we're adding 2 to I each time. Yeah, exactly, 5 times. It's going to run 5 times because it's going to start at 0, then it's going to go to 2, then it's going to go to 4, then it's going to go to 6, then it's going to go 8, and it's going to run all those times, and then finally it's going to hit 10, and it's not going to loop again because 10 is not less than 10. So it'll run in total 5 times. Let's see here. What if we did that? Well, let's see here. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep, 15 times. It'll run 15 times. Confusingly. But yeah, this will run 15 times. How about, right, exactly. It's not gonna loop on 0, but it's gonna start on 15. It's not gonna go down to 14 before it even starts running. The first time it runs through this loop, I will be 15, and then I will be 14, and then it will be 13 and 12 and 11. So adding on the additional time that I runs at its starting value, we actually arrive at 15. How about that? How many times will the loop run with that? It won't run an infinite number of times, actually. It'll run 0 times. Because as we see, I starts at 15, and the loop only runs as long as I is less than 0. And since it's never less than 0, it never runs. Even though we have the decrement here, that only happens whenever the loop runs. As long as the loop runs once, this part will do math to I. If it never runs, it'll never do math to I. So this will never run. How about that? Yep, it will run an infinite number of times. That is true, because we start at 15. It runs as long as I is greater than 0, but I keeps going up every time it runs. So it'll become 16, then 17, then 18, then 19. technically speaking, it won't actually run forever because of weirdnesses that involve maximum variable sizes and stuff like that. So there is a point where you will, it's some absurdly large number, but yeah, there is a point where you will actually, through variable magic, hit a point that is less than 0, even though you're constantly incrementing. But functionally speaking, it don't happen. And a lot of times compilers have built-in infinite like loop protection. So that will trigger before you actually roll over and come back to the negative values. But yes, assuming infinite memory, it would run forever and never end. Which is fun. But yeah, so that's the point I want to get at, is for loops can be controlled. There's a lot of control in for loops. You have a lot of control over the parameters of the for loop. However, there aren't a lot of safeguards necessarily built in. So errors in your logic can result in loops that never run or run forever, or run in basically an undesired number of times. Really, it can be reduced to that. They'll be run an undesired number of times. And so for that reason, you want to be sure that you're always thinking about the proper logic when you're creating a for loop. Now, with that in mind, we're actually going to go ahead and set up our first for loops inside of our code. So we're going to have one for loop in each of our functions. And this is what we're going to do. We're going to say integer I equals some number. I'm going to skip it for now. I is less than some number. I'm going to skip it for now. And then I plus plus. Here's a small little quiz to get you thinking. What do you think we're going to set I to in the first and second areas? Okay, yeah, you got the first number. What about the second number? We don't actually. And that's the tricky thing, Jacob. We did it so that we could learn a little bit more about variables, but we don't actually have to make an LED pin variable. We can do this all without it. Not quite, Noah, but your second number that you put down, that one is important. And think about why that might be important. And remember, this integer I, we can use this inside of our loop. You'll see what I mean. Okay, let me do this. So the first number we've gotten, it's 2. What about the second number? Take a look at our Arduino again. Yep, you were exactly right. Our second number is going to be 10. Why might that be, you might ask? Well, so I starts at 2, and the loop runs as long as I is less than 10. Notice how there's no LED plugged in to 10, as long as it's less than 10. So that means it's going to run from 2 to 9 and then stop. Yeah, 8 LEDs, 8 pins. Specifically these ones, which is why we're starting at 2 and we're ending at 9. So now here's the thing about being able to use I inside of a loop. What is the command again? Pin mode. Okay. Pin mode I output. Look at what I've done there. This I gets replaced with whatever the value is for I at that particular loop iteration, at the particular iteration of the loop. So the first time it runs, I is going to get replaced with 2. So pin mode is going to be called on 2, and 2 is going to be set to output. Then I is going to get incremented, so I becomes 3. Pin mode is going to get called on pin 3. That's going to be set to output. Then 4, output, 5, output, 6, output, 7, output, 8, output, 9, output. And then it's going to hit 10, and it's going to go, it's not less than 10, and it's going to move on to the next thing. So with these 3 lines right here, we've set all 8 of these pins to be output pins. Now, let's take a look at the second one. What's this going to be set to? Not quite. The answer is easier than you might think. I think I tripped you guys out by asking it again. Yeah, so it's going to be 2. How about this? Yeah, we're just iterating through the same numbers again. And we're doing that because we want to affect the same pins again. That's all. So don't be fooled by the fact that, like, I asked you, hey, what is this going to be? It's going to be literally the same numbers as it is up here because we want to affect the same pins. We're asking the Arduino to send power out on those pins. So here we go. Digital write I high. Delay 500. Digital write I low. Delay 500. And once again, I is going to be populated with whatever I is holding at the time. So the first time it runs through this loop, it's going to turn pin 2 on. It's going to wait half a second, then it's going to turn pin 2 off. Then it's going to wait half a second, hit the top of the loop again, I is going to become 3. Pin 3 is going to turn on. Wait half a second, pin 3 is going to turn off. Wait half a second. You get the idea. Now here's the crazy thing. We wrote this, right? This program is done. Let's compare the two. This is exactly how much loops have helped us, which is to say a lot. I mean, granted, we didn't have to have these variables up here. We could have replaced these with actual numbers, like this could have been 2 instead of LED pin 1, and this could have been 3 instead of LED pin 2, blah, blah, blah. But even assuming that we never declared those variables, look at how much space these loops have saved for us. Look at how much typing we don't have to do thanks to loops. Like, this is crazy. Loops are super powerful. Loops can also be misused. They can be used for evil instead of good. But by and large, loops are incredibly useful. So there you have it. We've taken something that could have been super annoying to write and turned it into actually a very neat and compact program using the power of loops. So here, I'm going to go ahead and put this code into the chat box. I want you guys to create the same thing. You can copy paste it if you'd like. I would encourage you to try and type it out on your own, looking at, my code as little as possible. Think about like the for loops and how they work and stuff like that. And then once you've done that, go ahead and copy paste it into your code editor in circuits.io. And then raise your hand. Okay, one hand. Alrighty, two hands. Three hands. Four hands. Six hands. All right, so I know not everybody has it. That's okay. We still got a couple people who are typing it out, but I just want to show you what happens when I click upload and run. And there you go. We've created What do you mean? The whole code's in there. You mean the loop part? Like void loop? Because the whole thing is in chat right now. There's no part after that. I was showing you guys how loops worked, but that's not part of the code. Yeah. That's why I deleted it. So there you go. Now your LEDs, one at a time, will light up and then go out. Now, how do you think you would make it blink faster? Like go through each one faster? Exactly. You'd reduce the delay time. In fact, if I was so inclined, I could actually, let's just comment them out. We'll comment out the delays on each of these and upload and run. And now it's just like on all the time because it's going through them so fast that we can't actually see them turn off. Let me stop the simulation and we'll reduce the delay to 100, so 1/10 of a second. Upload and run. We could even do 1/100th of a second. And we got this nice flickering effect. I'm going to do something a little wacky here. Yeah. Oh, I'm sorry, Andrew. That's no fun. Well, I got the circuit up here in case you want to reference it. It does. Good point, Noah. Yeah, I'm going to do something a little weird here. So we can do less than, we can do greater than. We can also do not equals to. And so that's what I'm going to do. I'm going to do plus equals 2. And I'm going to say if I equals 10, then I equals 3. So this is going to be a little interesting. Does anybody have any guesses as to what's going to happen here? Explosion? That's a good guess. Here, I'll go ahead and I'll just upload it so you can see it. I'll slow it down a little bit so you can actually tell what's going on. It's skipping, and then it's starting. Whoops, I see. I did something wrong here. A few corrections in my logic, and now we have nice alternating LEDs. So let's bring that delay down to 50 and see how it looks. A little bit too fast. Maybe 75. So you can do all sorts of stuff like this. It goes through each even numbered LED, and then it goes through each odd numbered LED. Using the power of math. Now my little check here is probably not the best check. This second one right here, where it runs as long as I is not equal to 11. Why might that be a bad idea? Compared to how we had it before? Confusion, yes. That's definitely a possibility. Confusion on the Arduino's part, confusion on the reader's part. What is it relying on? Like, what needs to be the case in order for this loop to end? It must equal 11. Exactly. Exactly. There is only one number that ends this loop, and that is the number 11. Whereas before, where we had I is less than 10, any number 10 or higher could end the loop. So it could be 10, it could be 11, it could be 12, it could be 13, it could be 14, it could be 155, it could be 3 million. As long as it is higher than 9, it will end the loop. Let's say I had a mistake in my math, and I accidentally made this, 12. Now we'll notice something. The loop runs once. And then these last two blink up here a couple of times, and then it's back to business as usual, which is nothing. The reason why that's the case is because any number higher than 11, it's useless to us because we only have LEDs plugged into these right here. Totally useless to us. However, it's not useless to the loop. The loop doesn't end unless it hits 11. If we accidentally skip over it, say we hit 12 and then we start going 12, 14, 16, 18, 20, blah, 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 loop's like, okay, well, we're still here, so I'm just not going to exit this loop. And we're going to sit here going like, why don't our LEDs continue to light up forever? Like it is from what we can see, it goes through its cycle once very nicely, and then it stops. So that's where our issue comes in. We want to make sure that we're ending our loop exactly when we want to. If we were in a situation where we only wanted the loop to end when we hit 11, then we could do this. Like if copy paste your code into the question box so I can take a look at it. If we were in a situation where every number was useful to us except for the number 11, then we could do this. But that's not the case. Everything including 11 and beyond. Okay, so copy paste your code. You might have some extra stuff. Everything beyond is useless to us. Up and down and up and down. You would need a couple of loops for that. Excuse me, another sneeze. But yeah, you would need a couple of loops for that. Think about how that might work. Also, Andrew, oh no, never mind. But yeah, definitely copy paste your code and put it into the question box, Andrew. Just like select everything you've got in the code editor. Make sure you got everything. If you want, you can hit Control A, and it will select everything that's inside that text box, and then copy paste it. But yeah, we could totally we could take this and return it to back how it was. Boom. Get rid of this conditional here. Boom. Turn this delay down to 50. 50. And then we could create an identical loop right underneath it. Except it starts at 9, and as long as it is less than or greater than 1. So when we upload it, oops, it's because I forgot something. Yes, I did. I totally forgot a thing. Forgot a couple of things. There we go. Upload and run. Up. And then down. And then nothing. What is happening? Everything's freaking out. Oh, that's why. I forgot to make this minus minus. Yes, you were supposed to delete the code that was already there. Yeah. Yeah, definitely. You've got way too much code there. Yeah, you replace whatever's there with this code. There we go. That was my issue. I forgot to subtract 1 from I each time it ran on the second loop, because I'm a dingus. But there you go. Back and forth. It's like very boring Pong. True. That is technically true. You have a good point there. So let's do that then. Yay! And in fact, we would make it so it's like this. So it only runs the bottom one once as well. And we can nest the loops and do all kinds of crazy stuff. So let's see here. I'm going to delete this, and we'll say k equals I plus 1 as long as I is less than 10, and I plus plus. Connecting the Arduino to the, you click on a pin hole, and then you click on where you want it to go. Okay, well, double check how all your connections are. Do you have um, the you figured it out? Okay, cool. That's not right. Oh, that's why. And then that's also not right because I forgot about this. Why aren't you working? There you go. Almost sneezed again. So now at this point, we're just sort of messing around with all the different things, the patterns you can make using loops and stuff like that. Okay, why don't you copy paste your for loop and void setup, and let's see what's going on with it. What is saying is wrong with it? Like, is it giving you an error message? And if so, what does that error message say? Because that looks fine. Also, for everyone, if you're so inclined, you can check out that updated void loop just to see what exactly is happening there. It says error. It should say something else too, like error because blah. Like if I were to get rid of the semicolon here and I hit upload and run, it would successfully compile because didn't actually delete the semicolon. Here we go. Bam, upload and run. See how there's at the end of input. Okay. Can you copy and paste your whole void setup into the chat box just so I can get an idea of what exactly is going on? Oh, it's void loop? Okay. Well, what's going on with your for loop and void loop? Or actually, just copy paste your whole void loop into the chat box. All right, let's see what we got here. Oh, you're trying out my code. You need an extra closing curly bracket. That's what it is. You have one too few. All right. Okay, so that it actually puts us right at 750. A nice easy class for today. You still won't work. Okay, what doesn't work about it? Is there an error message that pops up, or in the meantime, let's do poll questions, and then I can help you guys out with your circuits and stuff like that, and then we can break for the weekend and meet up again on Monday with inputs. So yeah, here we go.